On October 23rd, 2021, history will be made when university teams compete to win the Indy Autonomous Challenge, the first head-to-head high-speed autonomous race at the Indianapolis Motor Speedway. The teams are designing artificial intelligence to drive a modified Dallara IL-15 specially designed race car. The team which crosses the finish line first wins $1 million.
The Indianapolis Motor Speedway was established over 110 years ago to test new technologies.
And now self-driving cars are the next grand challenge in automotive technology. But we're still a ways away from having the autonomous vehicle that can drive anywhere and everywhere. We knew that there was a major leap that had to be taken. What better way to do that than a high-speed race at the most famous racetrack in the world?
The Indy Autonomous Challenge, it's unlike any other challenge.
30 teams from around the world, 20 laps, $1 million grand prize.
Our cars here at the Indianapolis Motor Speedway touch 240 miles an hour.
The minute that car is on the track, it has to control itself entirely.
It's racing, but in a futuristic way.
So how do you engineer an autonomous race car? First, you need a race car. Meet Dallara. Second, you need an engineering plan to modify the race car. Meet Clemson University's International Center for Automotive Research.
So about a year and a half ago, we met up at the Indianapolis Motor Speedway with a group of people that were trying to form the Indy Autonomous Challenge. So they really wanted the project to center around artificial intelligence and have universities from around the world to compete in a competition. They didn't really have the resources at the time to design and build the car. But luckily here at Clemson, we have this program, Deep Orange, where we actually design and build prototype cars as part of our educational process with our students. So it was a natural fit for Deep Orange to take on the project of designing the common vehicle that would be used for the Indy Autonomous Challenge. We have to find ways to replace the driver. So we have to find ways to see like the driver would normally see. So we're using things like LiDARs, radars, cameras, GPS systems. Then the car has to think for itself as well, which is the onboard computing. We have multiple computers on board the vehicle. And then the last part that we're dealing with is the act. And that is all of the actions that the driver would normally do, which is steering the vehicle, braking the vehicle, potentially using the clutch or also using the throttle. And so we have what we call drive-by-wire systems for that to take over what all the driver's actions would be. And so all of that has to be automated.
One area that we're really excited to see is how the learnings from this program is going to apply to the commercial world. Whenever you tackle a leading edge, completely audacious goal of having a autonomous Indy car going at 200 miles per hour, what we learn from here is directly applicable to the commercial world. And here's a use case, where we're really pushing the boundaries of what autonomy will actually show us it can do. An objective that the industry is trying to solve with commercialization of these technologies and helping students, our future leaders, get there.
The Indy Autonomous Challenge approached Clemson to design and build this vehicle because we have this unique Deep Orange program. No other university in the world has the facilities that we do, the faculty and staff that we do, and also the academic framework that we do here in the Department of Automotive Engineering to execute a project like this. The previous Deep Orange projects really showed them that we can execute professional vehicles at the end of the day. And what is very unique about Clemson is they're doing that, they're integrating this vehicle and all of these different partners together while also educating the students.
Third, you need the hardware and software components to make the Racecar autonomous. Here we profile our partners AD-Link, New Eagle, RTI, and PWR.
The intelligent machines of tomorrow are being developed right now, and New Eagle is driving that innovation by working alongside engineering teams to get their autonomous, electric, and military systems to production faster. As a mechatronics engineer, I saw firsthand how frustrating it was not to have the ability to write software that controlled the system. We developed the specification, but we had to wait for the software to be written. Raptor is our solution for this. A wise chief engineer once told me that we built the mechatronic engineer's software tool. Raptor enabled the mechatronics engineer to solve the real systems problem, saving time with fewer headaches along the way. We also match Raptor with a good supply chain. Our Raptor tools, along with the off-the-shelf validated hardware, make us a one-stop supplier for smart machines. Finally, Raptor is our secret sauce. It provides us the ability to write software quickly, enabling to find the real mechatronic solutions.
We're located in Ann Arbor, Michigan, a booming technology hub just 40 miles west of the automotive manufacturing capital of the world. Our Ann Arbor campus garage is always humming with activity. We are constantly looking for ways to help our clients balance their priorities, including cost, while still meeting their project requirements and maintaining industry safety standards. We have helped put hundreds of intelligent machines to work on the road, and we're just getting started. If you're ready to take control and get your vehicle into production faster, contact New Eagle today.
The race to build the vehicles of tomorrow is on. And in this high-speed race, the route to market can be full of hairpin turns with no margin for error. At every stage of the project, every decision needs to be the right one. Connex Drive can help you accelerate your journey. Connex Drive by RTI is the first complete connectivity software framework for autonomous vehicles, from design to prototype to production. Based on the DDS standard, Connex Drive manages rapid data exchange through a flexible, open, and highly scalable framework. It works through a data-centric data bus, allowing data to flow when and where it's needed, securely, at scale, and with high resiliency. Built on the DDS standard, RTI supports ROS2, AUTOSAR Classic, and AUTOSAR Adaptive, giving OEMs and suppliers the confidence they are investing in future-proof technologies by adapting to the needs of different ecosystems and platforms. With Connex Drive, you can reduce time to market, optimize performance, and ensure your vehicle has the flexibility needed for tomorrow's unknown challenges. From research to production, Connex Drive gets you there. Connex Drive, trusted software for tomorrow's vehicles. Take it for a test drive today.
PWR Advanced Cooling Technology is a world-leading advanced manufacturing facility with highly skilled staff and customized equipment and processes, enabling the design and manufacture of bespoke thermal solutions that are world-leading in the areas of application. The company has grown considerably from its origins and now embraces a unique blend of expert operator skill sets while utilizing latest technology equipment and process to produce high-quality product to exacting standards. Our thermal testing and evaluation capability provides a background in product validation that delivers confidence in our solutions. PWR is diversifying its product range, its manufacturing capabilities and market sectors to position the business as an exceptionally capable high-technology manufacturer. Vacuum brazed and CNC machined liquid cooled cold plates for high powered electronics cooling applications is now a primary capability. To support this and other new capabilities of the business, PWR has substantially invested in the commissioning of industrial CT scanning capability alongside of our manufacturing departments to support the quality assurance processes for key new markets. PWR offers a complete end-to-end service to its customers, from initial concept design through performance predictions and simulations and onto design for manufacture to suit either low volume and highly specialised thermal applications or volume production manufacture. At the core of PWR's key strengths are its innovation of product and process and the unique ability to produce final product solutions by various production capabilities. The flexibility of design, the control of product and delivery commitment that PWR is able to offer its global customer base provides a new benchmark in advanced cooling technology.
Fourth, you need the expertise to put all the components in the race car. Configure the car with drive-by-wire. Sixth, you give the race car the world's smartest and fastest tires.
Bridgestone's mission has always been about serving society with superior quality, supporting people's movement and lives with tires and other rubber products. As society moves forward, mobility changes. And we'll continue to apply our care, confidence and creativity to evolve beyond rubber to innovative materials and technologies. From Earth into space. Driving, turning, braking, transmitting and connecting. Creating new value. Bridgestone is evolving as a sustainable solutions company. With our innovation, we're developing solutions with our partners to the problems faced by society and our customers. Co-creating social and customer value to contribute to people's advancement on their journeys. Bridgestone, solutions for your journey.
Seventh, test with engineering simulation from a global leader.
The primary simulation software used in the Indy Autonomous Challenge is ANSYS VR Experience Driving Simulator powered by Scanner. ANSYS VR Experience Driving Simulator is a full capability autonomous vehicle simulator used to prepare terrain models and driving scenarios and to conduct in-the-loop simulations, including model in the loop, software in the loop, hardware in the loop, and driver in the loop simulations, and to analyze results and generate test reports. ANSYS VR Experience Driving Simulator is used to run thousands of simulations to test all possible situations that an autonomous vehicle could encounter in everyday driving. In the Indy Autonomous Challenge, it is crucial for the race teams to test their virtual driver software over thousands of different situations that could happen on the racetrack so that they can program the virtual drivers to navigate safely through all the different situations and perform the best maneuvers to win the race. Along with ANSYS VR Experience Driving Simulator, ANSYS has provided the race teams with a virtual model of the Indianapolis Motor Speedway oval racetrack on which the actual race will be conducted. ANSYS has also provided the race teams with a virtual model of the race vehicle. The Indy Autonomous Challenge race vehicle is based on a Dallara Indy Lights chassis. Students and faculty members of the Deep Orange program of Clemson University are integrating the powertrain and sensor suite into the Dallara vehicle. The ANSYS team works closely with Dallara and Clemson University to create a virtual model that is as similar as possible to the actual vehicle specifications. The hackathons are fun competitive events in which the race teams first receive formal classroom training on various aspects of simulation and are then provided with some race challenges. Teams conduct simulations of the race challenges and submit their work to ANSYS. ANSYS then analyzes the team's work and holds a fun mini race event where the teams see how they performed in the challenges as compared to the other teams.
Eighth, get the best students from around the world to develop AI to compete in the world's first head-to-head, high-speed autonomous racing competition.
The Indy Autonomous Challenge is a head-to-head, high-speed race of fully autonomous vehicles at the world-famous Indianapolis Motor Speedway. The talent that's showing up is just unparalleled.
When we saw this opportunity come up, that just seemed like a great opportunity to get involved. I've done slower vehicles, probably 20, 25 miles an hour, and to go at speeds of like 200 miles an hour seemed like a really interesting opportunity to do something that hadn't been done before.
You're traveling at such a fast rate that a lot of your sensors, by the time you get a new update, you're already multiple meters ahead, and so your algorithms have to keep up. My name is Nayana Suvarna. I'm currently a senior undergraduate computer engineering student from the University of Pittsburgh, and I know that women are often underrepresented in the robotics as well as STEM field. So I'm very grateful that I have that opportunity to be in this position where I can lead a team.
This truly is a global competition that brings together some of the brightest AI minds from around the world.
In Italy, racing is something which is really a classical heritage of our culture. It's in our DNA. Competition and racing is a very simple and undisputable way of assessing the quality of what you're doing.
Having 10, 15 cars on the track simultaneously creates a ridiculously complex scenario. We are the sole German team entering the competition. There are no lanes, there are no real rules, and you really have to understand what the other people are going to do.
When we're designing our software, we're really trying to mimic the way that a human race driver would be driving the car. All these teams are really talented, and so to be able to beat them, you can't do it casually. You have to really give it everything.
In motorsport racing, there is a saying that if everything seems under control, you are not going fast enough. Traveling at such great speeds, you don't have the luxury of time to figure things out. Right? By the time you figure things out, you're already there.
The more risky vehicle may just win, but the more risky vehicle may also be the one that crashes on turn one. We really don't want to mess this vehicle up, and so that's why safety has been one of the biggest things we've been striving for. I imagine a lot of tech will come out of the Indy Autonomous Challenge for sort of high-speed maneuvering for safety reasons.
We're also very fortunate to have Clemson University's International Center for Automotive Research. It's that traditional open-wheel race car format that fans are used to seeing at the Indianapolis Motor Speedway. It screams when it's going all out at 200 miles per hour. The performance is going to be intense and the competition's going to be fierce.
And that's how you engineer an autonomous race car that can drive at speeds up to 200 miles per hour with control, perception, and high performance at the Indianapolis Motor Speedway.